Question 1. Consider an experiment of tossing two coins and rolling a dice simultaneously. At X denotes the total number of heads, and Y the number that come up on the dice. So we have two random variables. X represent the total number of heads, and Y represent the number shown on the dice. The goal is to find the jam probability for all combination of X and Y. First, let's determine the possible value for X when tossing two coins. Hit, 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 and tail, hit, and tail, tail. Probability could be 1 over 4. Also, 1 over 4, 1 over 4 is 1 over 4. 2 hits, 1 hit, and 0 hits. The sample space for X is 0, 1, and 2. The probability 1 over 4 plus 1 over 4 equals to 1 over 2. Right now, we're going to find our sample space for the numbers upcoming in the dice. 1, 2, 3, 4, 5, and 6. Calculate the probabilities for each combination of X and Y. The probability of any specific Y is 1 over 6. Probability to choose P, X, or Y. X times PY is Y. Our gen probability distribution table will look like this. We're going to find the original distribution of X and Y. Original distribution is the sum of every row and the sum of every column. 2Y and S1 X. 1 over 24 plus 1 over 12 plus 1 over 24 equals to 1 over 6. 1 over 24 plus 1 over 24 plus 1 over 24 or 6 times will equals to 1 over 4. And while on the 1 over 12, it would be 1 over 2, 1 over 4 again. The next question, which is determine the whether X and Y are independent by using this formula. X, Y is equals to Fx times Fy. For example, we choose F01, which is our X coordinate would be F0 times F1. 1 over 24 equals to 1 over 4, 1 over 6. This will equal to 1 over 24. Since both values are equal, you can say that X and Y are independent. So right now, we're going to find the mean and variance for W is equals to 4X minus 3Y and plus 5. For the mean, it would be EW is to E X and 3Y plus 5. Variance of W will be 4X minus 3Y plus 5. And now know sum of X and Fx is 0 times 1 over 4 plus 1 times 1 over 2 and plus 2 times 1 over 4 equals 2. Find our mean for Y. The mean for Y, or expected value for Y, would be 7 over 2. Our expected value for X is equals to 1, and expected value for Y is equals to 7 over 2. EW would be, which is 4 times 1 minus 2 and 7 over 2 plus 5. Negative 3 over 2. VW will be V 4x minus 3y plus 5. It would be 3 over 2. Our expected value for EY square, 91 over 6. We already find our expected value. So right now we're going to calculate the variance for y and the variance for x. The variance for x would be 3/2 minus 1 squared, which is equals to 1/2. Variance for y, 91/6 minus square of 7/2, 35/12. We do it like before, equal to 137/4.
Okay, so we'll be moving on to question 2. Let the joint probability density function of y1 and y2. So what we can see here is this is the joint probability density function, and the range for y1 is 0 to 1, and for the y2 from 0 to k. I let the y1 equals to x and the y2 equals to y. For the first question, A, find the value of k. I'm gonna using this formula, which is the double integral of joint probability density function will be equal to 1. I'm using the joint probability density function here, and I integrate the x variable, which is our y1, from 1 to 0. So after I done integrate this equation, I'll get y square, which is after that I substitute this value of k and 0 into this. K square equals to 1. I'll get k equals to 1. Next, question B. Find the marginal density function of y1 and y2. So we're going to separate the work into two. First one is for marginal for y1, marginal for y2. So we are using this formula, which is for two variable, which is the x is for the y1 and the y is for the y2. This is how I do it, which is I integrate the y variable. After that, we will get this answer, which is 2x cubed plus 1/2. Okay, we'll be moving to marginal for y2. Right now, we are integrate it to the perspective of x, which is our y1. After I've done the calculation, and then I got y plus y, which is equals to 2y. Question C. Determine whether y1 and y2 are independent. So if it is independent, the value of these two multiplication will equals to the joint probability density function. And then after I multiply this, I'll get 4x cubed y plus y. What I can conclude here is that fxy are not independent. Question D. Determine P 1/4 less than y1 less than 1/2 given y2 equals to 1/2. For this case, we call it as conditional probability. I'm using this formula, which is px given y. We are going to use the joint probability density function over marginal of y. And then I will sub y equals to 1/2 because it is given here y2 equals to 1/2. I'll get 2x cubed plus 1/2. I'll integrate it from 1/4 to 1/2 to the respect of x. I've got 9/32 minus 65/512, which is after we solve this, we will get 79/512. Okay, last but not least, we'll be moving on to question E, which is the last question for question 2. Find the mean of P equals to 5y1 minus 2y1 plus 8. So here, I'll just add the E in front of them. For expected value, or we call it as mean, we will add x to the integration. We will multiply it with the marginal for y1. So the mean is 3/20. We will substitute the ex EX, which is I substitute 13 over 20, 13 over 20. I'll get 199 over 20, which is, this is the final answer for EP. So that's all from us. Thank you so much.